Maths up, everyone! For today's video, we will discuss a new topic under basic calculus, which is limits. Our goal for today is to understand the basic concept of limits and evaluate and illustrate the limits of functions. To start off, the intuitive definition of limits says that suppose a function f of x is defined when x is near the number a, our constant. Then we write this notation, which can be read as limit of f of x as x approaches a is equal to L. To put it more simply, limits describe how a function behaves near a point instead of at that point. But remember that the limit of a function refers to the value that the function approaches, not the actual value. Now let us look at our graph to further understand the basic concept of limits. When it says that the limit of the function f of x as x approaches a is equal to L, it means that if we are given with the point, when x values gets closer and closer to that point, that will give us its corresponding y value or our L. And take note, we are going to consider two areas, from the left of the constant or the negative side and from the right of the constant or the positive side. Now let's move on to our example. Let us find the limit of x plus 3 as x approaches 2. There are several ways to solve this problem, but the first way to solve this is by substituting our constant for the value of x. So, in this case, just substitute 2 to the value of x in the function. This will be 2 plus 3. The answer will be 5. But remember what I've said earlier. This, which is our L, is not the actual value. It is just the limit of f of x as x approaches the constant a. And remember that sometimes you need to simplify the function first before substituting or doing anything else. The next way to solve this is by graphing. So, by looking at the graph of x plus 3, since 2 is our constant and we are looking for the limit as x approaches 2, just plot the point when x is equal to 2 in the graph. Then the answer for limit L is just at the corresponding y value, 5. For the last method to evaluate limits that I'll discuss, we'll use substitution again. But now, we will substitute several values close to the constant and approximate. We can also use this method to check if we got the same answers from our previous methods or to check if we'll arrive at the answer or limit using several values close to the constant. Again, we have two areas that we need to consider: the negative side or from the left of the constant and the positive side or from the right of the constant. So, for example, let's use first 1.8, 1.9, and 1.99. which are values from the negative side of the constant for the values of x. We'll get these answers. As you can observe, every time we substitute values close to the constant, which is 2, we get closer to our L, which is 5. Hence, the limit of x plus 3 as x approaches 2 from the left is equal to 5. Don't forget to denote or represent which side you used using this. So since we used values from the left of the constant, we will use a negative sign. Next, let's try to use values from the right side of the constant. Let's use 2.2, 2.1, and 2.01. Let's substitute them to the function and we'll get these answers. And just like a while ago, as we substitute values which are close to the constant, we are also getting closer and closer to our L, which is 5. Hence, the limit of x plus 3 as x approaches 2 from the right is equal to 5. Since we used values from the right of the constant, we'll use a positive sign here. Remember, a limit must be the same from both the positive and negative sides. Now it's your turn. Try to solve these problems by yourself. Remember the basic concepts of limits I've mentioned earlier. See you next time as Archimedes awaits you. Subscribe to our channel and click the notification bell to be updated for our next video.